second question through is also worth 10 marks. We've got a 5 kilogram mass initially at rest on a smooth horizontal surface. So there it is. I've got a normal reactive force and I've got 5g moving down there. Resultant force of 2.5. So I've been given my resultant force and it's just a number and it's constant. Find the velocity and displacement. So I have constant force, r equals 2.5. Replace r with mass times acceleration. So my acceleration is a half. Therefore, I've got constant acceleration. I can use this rule and I can use this rule to find out what the velocity and what the position is after 4 seconds. So I replace t with 4. Okay, a new variable force. So this was a constant force, constant acceleration, a variable force, therefore variable acceleration. I can't use these rules. You need to use integration of some sort. So I've been given my new variable force. It's a new variable force that takes on after 3 seconds. So I'm going to have 3 seconds, then after 3 seconds, I've got this new variable force. So r equals 2.5 minus 0.5t. Replace r with mass times acceleration. Divide all of it by 5. This is an expression I have for area. Now, I need to find the velocity and the position of the mass after a further 3 seconds. So I'm going to replace my a with dv dt, then move the t over, anti-differentiate plus c. And I know that after 3 seconds, my velocity is 2. So I'm going to use 2 at t equals 0 to get this is my velocity, and I can put 3 into that and get 61 on 20 as being the velocity after a further 3 seconds. Then I can anti-differentiate this again. I plus d, and I use x equals 4 and t equals 0, and this gives me my position after 3 seconds. And then over the page, a new variable force again is applied, where x is the displacement, and I want to know the velocity after it has been placed a further 3 meters. Okay, so I now have a new variable force, 15 square root of x plus 1, 5a equals that. This is an expression for area. Since I want to know the velocity after another 3 meters, I want v with respect to x. Therefore, this is the replacement I'm having for acceleration. I'm doing separation of variables. Take the integral of both sides. To find c, I'm going to make v equals 61 on 20 when x equals 0. So on every new calibration, I'm going to take t back to 0, x back to 0, but bring in my v from the previous component so that I can work out what my constant is. And then once I know what my constant is, I can then find out what the velocity is when x equals 3 by subbing it all in. I've got 6.11. So that's how the second part of that question went.